Okay, we're going to talk about milking systems. So we got a series of three videos here that are going to walk us through what the parts of a milking system are and how they are in place at Morrisville. We'll probably add a pulsator for as a fourth video. I haven't figured out how I'm doing that one yet. Okay, so here are the parts of a milking system. This is the best diagram I've been able to find. Showing pretty much in a generic sense all the things that are there. So let's see if I can get my pointer up and running. Okay, so we start at the vacuum pump down here. This is a place that's going to generate the vacuum that we need to run both phases, the milking phase and the rest phase, to get the different pressures, vacuums in the milking unit that are going to get the job done. And it all starts at the vacuum pump. You've got the exhaust line outside. It sucks air out of the system and blows it out the exhaust pipe. You've got a main line running to a reserve tank somewhere in the system. In the older systems, when we're using steel lines around the barn, we had much bigger tanks. As we go to bigger PVC systems for our vacuum lines, we are getting smaller for the whole thing. So the idea is that the entire system has a certain amount of a vacuum in it, and in that vacuum, we have a certain amount of reserve that will help maintain that proper T-den pressure, help make sure that our outer chamber of the teacup alternates the way it's supposed to. Now, the reserve tank goes in two different directions. We have the pulsator line, and this is usually a loop in some way, shape, or form. We'll see that in the Morrisville system. We do have a loop, two lines going out, they loop together and come back. The idea behind that is to balance out, to make sure the entire loop is of even vacuum. If we had some sort of dead end, the physics of that would say that this end would be very different than this end over here. So we've got the pulsator line established that goes around, that provides vacuum to the pulsator. That's one of the two openings. Our pulsator is attached to the pulsator line, the vacuum line, and it alternates between drawing vacuum from the pulsator line and opening up to atmospheric air. So down this tube, we'll have two different environmental states, one under vacuum, which is equal to the pulsator line when it's connected to the pulsator line, vacuum in this line, vacuum all the way down into the outer shell of the teacup. And then when it's open or drawing from atmospheric air is going to go down this line and into the teacup and thereby collapse the liner, starting the rest or massage phase. So this whole section here is about establishing the atmosphere on the outside of the teacup. Now from the reserve tank, we go in the another direction to get to the inside of that liner in the milking unit. And we've got a long way to go that we work our way around. We get in the milk line and then we go into the long milk tube, the claw, and then down into the liner. So you have two different atmospheres or air systems meeting at each teacup. And that happens one going this way, one going this way over here. So we leave the reserve tank. We're going to head toward the inside of the liner in the teacup. We're going to pass the regulator. So the regulator is set up to kind of set a floor to the vacuum. How low can it go? And if it goes below a certain amount, the regulator will open up and put air into the system. So this is kind of a check and a balance, a floor. If you've got air running in the regulator and then just being pumped out the um, vacuum pump, you're looking at something that's really kind of a futile cycle. It's a waste of energy. That's why we've gone to variable vacuum pumps that, based on what the gauge is telling it, it will run more or less. And we have to let less air into the system, therefore dump less out going through. But that regulator is there to kind of protect the system just in case. When my dad, once the regulator went and it actually collapsed the whole reserve tank because there was so much vacuum in the system. So that regulator's there. It's a matter of finding it. We want to make sure that stays clean. The springs in there, the air can flow in as it can. The springs are moving the way they're supposed to. So we have a constant vacuum level. We don't have sticky points and fluctuations as it lets air in. We have a vacuum gauge somewhere in the system. We have certainly one in the Morrisville system down in the pit. We also have a, a duplicate gauge in the milking parlor that lets us know where we are and where we're supposed to be. So that vacuum gauge lets us know what the vacuum is. So we're more or less thinking about what the lines are, and then a few points lower vacuum than that is what usually ends up at the TDAN. So as we move through the system, we have a sanitary trap that's meant to protect all this equipment over here. The milk can only go so far, the wash water can go only so far before it'll shut off the system and not let it siphon liquid into this area. So we want the trap to be working, make sure that if it fills up to a certain amount, it'll shut the system off to protect the system. We don't want to have milk in this system. I dealt with that once in my life. I don't ever want to do that again. Trying to get that milk out of there and get it clean and not rusting, and it's just a mess. So that sanitary trap, the vacuum moves across the top of whatever liquid's in there and comes down into the receiver jar. The receiver jar has a layer or level of milk in it. So you're going from an area of vacuum on the top to an area down here where there's no vacuum, bolt tank, no vacuum. So as the milk goes up and down, you'll have trip sensors that'll pump out a lot of the milk. So that will be drawn out with the milk pump. It usually goes through some sort of sock and then ends up in the bolt tank. So it goes from a vacuum system to a non-vacuum system as it moves over to the bolt. That vacuum will go up the milk line, and again, we want a circle for the same principles we needed a circle for the pulsator line. We want to have uniform vacuum all the way through. We don't want to have dead ends that lead to lower vacuum and fluctuations therein. So we go through, we go down the long milk tube, through the claw, short milk tube, and we have the vacuum on the inside. So those are the parts of kind of a generic system. We need to make sure that we know what all these things do, and when it comes test time, you should be able to tell me what their purpose is and what they're doing. So quick review on that. Vacuum pump generates the vacuum. Reserve tank gives us a vacuum reserve. It keeps the pressure in both circuits, the pulsator line and the milk line, constant. The regulator is there to put a floor in the vacuum, making sure we don't go too low and protect the system. Vacuum gauge reads what that is. Sanitary trap keeps liquids from getting into the vacuum pump, which is a bad thing. The receiver jar is where we've got the transition of milk from vacuum system to a non-vacuum system. It keeps that what is that called? Keeps the pressure separated by not overfilling and not underfilling. The milk pump pumps things out. Bolt tanks where everything's stored. Milking unit extracts the milk. Pulsator alternates the outer chamber of the teacup. Milk line carries the milk to the receiver jar and the vacuum to the milking machine. pulsator line carries vacuum to the pulsators. So you look over here, colors, you got your vacuum supply, milk flow. This is kind of incomplete because you've also got vacuum going through. Look specifically on how kind of the Morrisville system is laid out. If you go in the back to the utility room in that southwest corner, you're going to have a vacuum pump. There are two of them there, as we'll see in the pictures when we get to those. We have two there, so we could run on one if we had to. That redundancy there allows for us to repair one while we're working on the other. Up top above it on PVC, you have your vacuum reserve, and that vacuum reserve has two sets of lines that generate vacuum that meets at the teacups in the parlor. So the parlor here, lobby this way, holding pen this way. So if we look at the vacuum reserve, that kind of goes out through the wall by the door there and up and does a circle above the parlor. The pulsators are up high, the pulsator lines are up high, and that goes down to the outside of the teacup, alternating between the vacuum and the atmospheric air to open up the liner and close the liner there. The vacuum reserve also has a line that goes along the wall here, goes through the wall in that far back corner and down into the pit, over the trap, into the receiver jar, and then through the stainless steel milk lines that run low in the parlor. So the vacuum on the inside of the teacup, the inside of the flexible liner, comes up through the bottom. So that's kind of your orientation. We'll go through, I've got pictures of each in our next slide, or next PowerPoint presentation. We're thinking about milking systems. We'll get more into this in a later lecture, but just to kind of think about it, we got to maintain and clean our system. So when we're looking at maintenance, we need to establish and follow schedules. We need to change and check when we're supposed to, and regular system diagnostics. So the things that you're going to do every day. There's the things you're going to check on a regular basis, a monthly basis, weekly basis, and we need professionals to come in and check our vacuum levels, make sure our pulsators are working the way they're supposed to, and our vacuum drops and that alternation between milking and resting phase are where they're supposed to be. So when we're cleaning, we got to think about cleaning all of that. I know I've told you that I got that PI count when I was a grad student because I didn't know about that little tiny ring that I was supposed to take apart and clean. Nobody instructed me on that, but it just didn't get done, and I was the one that will forever be reminded of that by the employees who lost their year premium because of one afternoon of work by me. We need to follow instructions, whatever's on our cleaning, timing, all those things, whatever's established by the manufacturer, whatever's established by the maker of the product. We need to follow those instructions. And from time to time, we need to really check our temperatures. So all this should be put up and put together in some sort of standard operating procedure that, do certain things daily. I'm going to do my weekly checks on Tuesdays. I'm going to do, monthly checks on Thursdays, whatever those things you might alternate through or however you want to do it. We need a standard operating procedure. What do we need to check? What needs to happen? All those things need to be going together.